and y values are switched, xy becomes yx. Inverse can be thought as undoing or reversing effect. Inverse is not the same, I can't repeat how much that is, not the same as a reciprocal function. A lot of students get confused and they think that this -1 here is an exponent, but it is not. So here's a first example. Here's a function. It's just composed of 4 points. If the function is 1, 2, 2, 4, 3, 6, 4, 8, what would the inverse be? Well, just a set of points reversed. So 2, 1, 4, 2, 6, 3, and 8, 4. Another way to show an inverse is if I give an equation, for instance, example number 2. If f of x is 2x plus 1, find the equation for the inverse. So what you have to do is replace f of x or g of x or whatever it's called, the function, with y. Sometimes this step is actually omitted, because in the next step you're actually switching the x and the y around, exactly what you do for the inverse. So then it becomes x equals 2y plus 1. So you can see why you might skip that first step. So now what you have to do is rearrange and solve for y. So move the 1 over, so I get x minus 1 equals 2y. Last step, 2y equals, sorry, I'll erase that. Last step would be dividing by 2, so y equals x minus 1 divided by 2. But then you have to rewrite it in the inverse format. So f with the inverse notation equals x minus 1 over 2, which means if I want to undo 2x plus 1, I would use this equation to undo it and get back to the original equation. So for instance, for f of x, we are multiplying the input by 2, then adding 1. So it's logical. The inverse would be taking the input value and subtracting 1, then dividing by 2, undoing everything. So find the inverse of this parabola algebraically. So first step, write it as y equals x squared minus 1, switch the x and the y around, x equals y squared minus 1, then rearrange so that you get the y by itself. Now in this case, you have to actually square root it, and you get plus or minus the square root of x plus 1, which gives you the sideways parabola going up and going down. That's why you have 2 of them. We can't call this an inverse function because it would not pass the vertical line test. But we knew it wasn't going to pass the vertical line test, or it wouldn't be a function in the inverse because it wouldn't have passed the horizontal line test. So how can we restrict the domain of g of x so that the inverse g would be possible? Well, if we only have part of the parabola, the positive part, so we could say x is greater than or equal to 0, then that means only this part would be the inverse, and that would pass the function test. Verify whether f of x equals 2x minus 1 and g of x equals x plus 1 are inverses. Note you have to find that they're inverses of each other if and only if they both become x. So we're going to rearrange. I'm going to skip the first step and just go directly to x equals 2y minus 1. X plus 1 equals 2y. Divide by 2, I'm going to get the inverse of x to be x plus 1 divided by 2. Looks good so far. So let's see if the g of x is now the inverse of f of x. So again, skip the first step. X equals y plus 1 over 2. Cross multiply the 2 over, I get 2x equals y plus 1. Subtract 1, I get that. So that means the inverse function is 2x minus 1. So therefore, they are inverses of each other, which means they would undo each other. graphing an inverse, we've already learned that they are mirror images in the y equals x line. So what you can do is you can take some critical points that are on the graph, for instance, those 3 on the relation. So let's point -2, 0, 1, 3, and let's say 3, 3. And the way to find the inverse is you switch the x and the y around. So this would become 0, -2, right here, 3, 1. And I'm just going to connect as I go. And 3, 3 would actually stay as 3, 3 because it's the same. A mirror image on the y equals x line. So what's the domain of the relation? That was the black one, and that would be x as an element of reals. What's my range? Well, it looks like my range only goes as high as 3, so that would be y is less than or equal to 3. So let's use shortcut this time. The inverse relation, we can see that for x's, x only goes as big as 3, so x is less than or equal to 3, and y actually in this case is an element of reals. Notice that the domain of the relation becomes the range, element of reals, and same with the range becomes the domain. Does that make sense? The x and the y switch. Okay, so let's do another one here. Let's pick a few points here since we have a w. So -3, 2, -1, 0, 0, 2, 1, 0, and 3, 2. Again, to find the inverse, you just switch the x and the y around. So this becomes 2, -3, 2, -3. -1, 0 becomes 0, -1. Again, I would draw it as I go, just to make sure. 0, 2 becomes 2, 0. 1, 0 becomes 0, 1. Our image in the y equals x line. My relation for the domain, it looks like it's all reals, which you can tell that the range now becomes all reals of the inverse. The range of the relation was 0 and up, so that would be y is greater than or equal to 0. And you can see that the domain of the inverse is starting at 0 going up, so x is greater than or equal to 0. All right, so to actually find specific values of an inverse, there's 2 methods that you can do that. You can find the equation of the inverse, then sub it in, and that's what we're going to do first. So again, the method was to change the x and the y around. The method is if you understand that the input of the inverse is the output of the relation, the original, then you just sub it directly into the output. So again, what I'm saying is this is the input, which was the output of the other function. So 2 equals 3x minus 2. Add 2, you get 4 equals 3x. X equals 4 over 3. So therefore, the inverse at 2 is 4 over 3. See, we get the same answer, except that we don't actually find this intermediate step of the equation of the inverse. So if it asks you for the equation of the inverse, you might want to do method 1. Again, we'll try method 1 here. So x equals 1 over y minus 2. Somewhere where we learned cross multiplying. So we do a little switcheroo. So we get y minus 2 equals 1 over x. And then the inverse, of course, would be adding 2, so 1 over x plus 2. So if I want to find g of the inverse at 12, it would be 1 over 12 plus 2, which is 2 and 1/12, which is 25 over 12. Again, method 2 says that this input goes into the output of the previous. So 12 equals 1 over x minus 2. Again, we have to do a switcheroo there. So x minus 2 equals 1 over 12. And x equals 1 over 12 plus 2, which is 2 and 1/12, which again gives me 25 over 12 as my final answer.